My name is James Park, and this is my lab 1. Alright, so the purpose. The purpose of this lab is to observe an object moving in constant velocity without changing directions in a certain time to see how the position versus time would look in a real life versus a perfect calculatable value according to physics principles. Now, models. How was the experiment done? To get an object in constant velocity, a can was used on a flat surface with a ruler for the amount of time to figure out the amount of distance traveled, and it was recorded and pushed with the hand to give it a little force in the beginning. And after recording, the tracker app was used to figure out the position versus time, and also using that we could figure out the estimated velocity to calculate the perfect position versus time that was found using glow script. Now, the fundamental physics principle that was used for this part was definitely Newton's first law, which is how an object will move in constant velocity only if the net force is 0. Okay, so let's look at the experiment. So on the tracker app, the experiment looks like this. So the can was pushed, and the can will move in a straight line in the path. And the tracker app was used to calculate these distances, and by calculating it and by analyzing the graph, we found that the variable or the estimated velocity, constant velocity, was this value. Now, using that value, we used glow script to code it. Now, to look at glow script, here's our code, and this right here is our estimated velocity. And by multiplying that with amount of time travel with the position, we were able to make the simulated / the perfect distance that it will travel with this velocity. Now, using the two data, we compiled it together. If you can see the first result, second result, and this here is the compiled together, where the x stats will be here and the x row, which like the one that was in the real world, will be on the bottom. Now we can see how the graph differs a little, where it's very similar, I would say, where the slope is going the same way, but you can see by the end, the position of the statistics, so perfect, the world is very slightly different than the real world. So why is that? It may be human error. Let's figure that out. The first thing, discussion. So main physics idea. So we have Newton's first law, net force 0 equals constant or not moving, and Newton's second law. If force is acted upon an object, you see here F equals ma, then the object will accelerate / move. Alright, and you can see Newton's first law here as well. And another way of looking at this is if force is put on throughout a time, then the velocity will change, which another way of thinking about acceleration, right? Okay, so before we answer these questions, let's think about why it could have happened, why the difference if you look back. So the real reason why it would be friction force, where we can't really calculate friction force because the friction of the table is unknown. That'll be why, and we can talk more further on this here. So what if? So let's answer these two questions. What if the x or negative x was interchanged, how would that affect the lab? Well, it wouldn't really affect it because we're only looking at the position and not really the direction of the position. So that really wouldn't do anything to the experiment. Now, what does this mean? Well, this question asks if you set the net force into 0, what would make it, or how many pushes would you need to make net force into 0? Well, this is really not possible to answer because in a simulated world, yes, if you push it in the beginning and then not push it again, it's going to go net force 0 throughout the whole thing, and then it's going to be the perfect world. However, in the real life, we have friction force, we have other things like air that we can't account for. Alright, conclusion. If force is given to an object is given a net force of 0, the object will move in a constant velocity. However, human error and other uncontrollable variables such as friction or air can make the equation very inconsistent. And that was my lab. Thank you for watching.